Assalamualaikum warahmatullahi wabarakatuh and a very good morning everyone. So today we reach at our final chapter of digital electronics, which is regarding the chapter 9, Programmable Logic. Okay, so in this chapter what you are learning is you are learning about the memory, RAM and ROM, and also programmable logic devices. Okay, so let's continue. So what is actually a memories in digital circuit? So memories are actually a device to which information is transferred for storage and from which information is available for processing. So basically in digital circuits, memory are used to store information and that information must be always available for processing. Alright? So in a digital circuit, it has two types of memories. So the first type is the random access memory. So the random access memory is actually a place of executing the operating system, application programs, and data current use are kept for quick access by processor. For example, if you are using a computer and you are opening an application, so that application is temporarily stored inside the random access memory in order for the processor to quick access that application in order to execute some operation. Okay. So the RAM contents are volatile. So what is actually defined as volatile? So volatile means that the information will be lost when the power is cut off. So for example, if you are shutting down your computer, all of the information stored inside your RAM will be deleted. Okay. So next, RAM is also known as read or write memory. Alright. So it can read and it can also write inside the RAM. Okay, the next type of the memories inside the digital system is ROM, read-only memory. So ROM is having the data is permanently stored, okay? And ROM is also non-volatile, so it means that it can hold its data when the power is removed. So it will retain the data which is being stored, okay? So ROM is actually used to start the computer up and also load the operating system. So usually in computer or inside the what we call Raspberry Pi, the the operating system inside is stored inside the ROM. All right. So next is what is actually the variation of RAM. So the integrated circuit RAM devices are available in two different variations. So the first variation is the static RAM. So what is actually a static RAM? So static RAM consists of internal latches that store the binary informations. So it is actually the stored information remain valid as long as the power is applied. So as long as the power is exerted, the data will be retained. Alright. Okay. So the static RAM is also faster, and it has, however, it has a high power consumption, and it is also expensive. Alright. So usually what you call a static RAM is being used inside your processor where it is used to store the cache, okay? And also it is used in your graphic card where it is used to store the frame buffer, alright? So next variation of the RAM is the dynamic RAM. So what is actually a dynamic RAM? So the dynamic RAM stores binary information in the form of electric charges on capacitors provided by most transistors. Okay. So the charge of capacitors tend to decay with time, thus it needs to periodically recharge by refreshing the dynamic memory every few milliseconds. So every few milliseconds it will recharge its memory. Okay. So the advantage of dynamic RAM is it has a lower power consumption and it has large number of memory words per chip. Okay, so usually the dynamic RAM is actually the conventional RAM that you are using in your computer. Okay, for example 4GB of RAM, 8GB of RAM. So that type of RAM is a dynamic RAM. Okay, alright, next is ROM. So what are the variation of ROM? So the first variation of ROM is the mass program ROM, MROM. So the mass program ROM is programmed by using a mask during the fabrication by manufacturer. So this type of mass program ROM is already programmed by the manufacturer. Okay, so you cannot customize the program. Okay, the advantage of mass program ROM is it is high speed, high density, and also it has low unit cost. Okay. So So the disadvantage is the contents are permanent because you cannot what you call customly program the particular ROM to execute some functions. Okay. So next we have the next type of ROM is you having the programmable ROM. So the programmable ROM is the contents are in form of fuses which are blown during the programming. Okay, once blown, the fuses cannot be restored. Okay, so the programmable ROM is a type of ROM that you can customly what we call program. Okay, by using some what we call applications. Okay, so the EPROM is one-time programmable OTP, one-time programmable. So it cannot be updated and reused after initial programming. So for programmable ROM, you can only program your ROM to execute digital function only once. Okay. So this is the example of an unprogrammed EPROM. Okay. So you see here, for ROM, it has inputs. Okay. It has decoder, and it has outputs. All right. So for the ROM, this is the what you call the area where you can program your ROM. Okay, so this is the programmable interconnection, which is being represented by the X marks. Okay, so in order for you to program a EPROM, you need to use a fusible link. Okay, so in order for you to store the value of 0, a current will be exerted and your link will be burned. And if you wanted to store the value of 1 inside your ROM, so the fusible link will left intact as it is. Alright? So the next type of ROM is the Erasable Programmable ROM, EEPROM. So what is actually EEPROM? So EEPROM, in EEPROM, it can be erased and reprogrammed many times. And the whole chip is erased by the exposure to approximately 20 minutes of intense UV light. So in order for you to erase the what we call information inside the EEPROM, you need to expose the device in approximately 20 minutes of intense UV light. So next type of ROM is the Electrically Erasable Programmable ROM, EEPROM. So for EEPROM, it can be erased and reprogrammed without requiring special burning equipment. So you don't have to expose your device into 20 minutes of intense UV light in order for you to erase. And therefore, it is quite high cost. Alright. So for EEPROM, it is also allows only one memory word to be written or erased at any one time. So this is the limitation of EEPROM, because it only allows one memory word to be written or erased at one time. Okay, next is the flash memory. So the flash memory has a very high speed and high density, and you can erase as many locations simultaneously. So it cover the limitation of EEPROM. But the flash memory can only tolerate about 10,000 erase operation before the device are fail. Okay. So this is the example of the question given for ROM. So given the truth table for 8x4 ROM as follows. Find the number of programmable interconnections and implements the ROM circuit. So this is the truth table where you need to implement your ROM circuit. So as you can see here, the number of inputs of ROM is 3 and the number of outputs for ROM are 4. Okay. So in order for you to find the number of programmable interconnections, so it is actually the possibilities of the input. So as you can see here, in this what you call 3 inputs, it has a total of 8 possibilities. Okay, so the possibilities of input will be multiplied by the number of output. So the number of output here we have 4. So we will have a total of 8 multiplied by 4 equals to 32 programmable interconnection for ROM. Alright, so this is the answer for this question for the implementation of this truth table inside the ROM what we call circuit. Okay, so for the ROM we have the inputs, and then we have the decoder, 3 to 8 decoder, because it has a total of 8 possibilities, so we need to use 3 to 8 decoder. Okay, and then we have the outputs D3, D2, D1 and D0. Okay, so how we wanted to get this type of circuit? So as you learned in your what we call previous chapter, so for decoder, if the input is 0, 0, 0, it means that the output 0 here is equals to 1. Okay, so you see here in each outputs there is no output which is equals to 1. So the pin 0 is not being connected to any of the outputs. Okay, so at 0, 0, 1, the pin 1 will become 1. Okay, the output of pin 1 will become 1. And you can see here at each output D3 until D0, there is no output is becoming 1. So it is not being connected to any of the output. Okay, so next you see when A2 equals to 0, A1 is equals to 1, and A0 equals to 0, pin number 2 will become 1. Okay, so as you can see from the output here, right now D0 is becoming 1. So it means that at pin number 2, D0 will be connected. Okay, at 0, 1, 1, pin number 3 will become 1. So you can observe at the output where is the output is becoming 1. So D1 is becoming 1 at 0, 1, 1. So it means that at pin number 3, D1 is being connected. Okay, next is 1, 0, 0 input. So at 1, 0, 0, pin number 4 will become 1. Okay, so which outputs are becoming 1? So D2 is becoming 1. Therefore, D2 will be connected to the pin number 4. And so on. Okay, so you can just design your what we call ROM circuit by observing the input possibilities and the output. Okay, so which output is become 1, and you can just connect it at that particular possibilities. Okay, so next part of this chapter is the Programmable Logic Device, PLA and PAL. So what is actually a Programmable Logic Device? So Programmable Logic Device consists of general purpose logic resources that can be connected according to the engineer's design. So later on we will become engineer and we are using a Programmable Logic Device. So we can design our own logic circuits and our own logic functions by using PLD. Okay, so it must be programmed first before it can be used in the circuit. So of course, if you want it to use in the circuit, we need to program the PLD first. So the advantage of PLD is it needs only fewer parts and it reduces inventory costs, okay, because of the fewer parts needed. And the number of interconnections are decreases as more logic integrated into each chip, and it has higher reliability. Okay, so the disadvantage of PLD is it has longer propagation delay and it has high power consumption. All right. So the example of PLD are ROM. So ROM we already learned in the previous slides. PLA, PAL, and also GAL. So these three, PLA, PAL, and also GAL, are going to be learned in this subchapter. Alright. So this is the three configuration of SPLDs. So you see here, for ROM, which is we are being what we call studied in the previous slide. So ROM has fixed and array, and you can program the OR array. Okay, but for PLA, it has a programmable AND array and programmable OR array. So you can program each array. Okay, so for PAL and GAL, it has programmable AND array, but it has fixed OR array. Okay, so later on I will show you what is actually OR array and what is actually an array. So first we go through the PLA. So Programmable Logic Array, PLA, consists of programmable AND and OR arrays. So both arrays are programmable. So this PLA is advantageous when it is relatively few unique min-term combinations. Okay, so if our circuit requires a few unique min-term, so this circuit is very advantageous to be used. All right. So many min-terms are shared among the output functions. And the drawbacks of this PLA is it is expensive to manufacture because it has a lot of interconnection which is programmable. Alright, so it also has poor speed performance. Thus, PEL and GAL were introduced because of the poor speed performance of PLA. So PEL and GAL are introduced. Alright, so this is the logic configuration of the PLA, where this is the AND array. So this AND array is programmable. Okay, so it is called AND array because it is connected to the AND gate. okay? And this is the programmable OR array because it is connected to the OR gate, okay? So both AND array and OR array are programmable. So you can custom design your logic circuits by using PLA. Okay, so it is easier for you to design because you can customly design and you can design it as you want. Okay. Okay, for example, so implement the following logic function using PLA. So you have a total of 4 functions, W, X, Y, and Z. Okay, so based on this function, it means that you have a total of 4 outputs because you have different functions. Okay, so this is the answer for the questions. So you see here, in order for us to implement this following logic function, you can just implement it by connecting the correct connections to the circuit. Okay, for example, this is input A. So the output that comes from this line is A, and the output that comes from this line is A bar. Alright, similar to the B and similar to the C. Okay, so we'll take a look at the function W first. So W equals to A plus B bar C bar. So in order for us to program it for the W, we'll program it B bar. Okay, we need B bar, we need C bar. So you can just program B bar and C bar, and you can connect those lines at W. So W will be equals to C bar, B bar, plus the other one is A. Okay, A. So A plus B bar, C bar equals to W. Alright. So next is X. X equals to A C bar plus AB. Okay. So for this one, you see here, we need to program AC bar first. So to program AC bar, you can just connect A here and also C bar here. So A C bar will go through the AND gate. So this is the output of AC bar. So AC bar will be connected to output X. Okay. So AC bar plus AB. So AB, A is connected and B is connected, and both are connected to the AND gate. Okay. So the AND gate will be connected directly to the X output. So A bar, AB. Okay, this is AB, and this is A C bar plus. Okay. So you can just directly program your own logic circuit by using PLA. Alright, because it has programmable AND array and programmable OR array. So you can just simply program your PLA circuit. Alright. So next is PAL. So Programmable Array Logic provides an array of programmable AND gates, but the OR connections are fixed. Okay. Unlike the PLA, the product term cannot be shared among gates. Okay. So this PAL is advantageous because it is cheaper and it is faster compared to the PLA. Alright. So this is the PAL or GAL general configuration. So you see here, the AND array is programmable, but the OR array here is already fixed. Okay, so you cannot program your own OR array. Okay, so for example, if DO has the output of AB plus A2 A1 plus A1 A0, so you can just program inside the programmable AND array because this connection is already fixed. So for PAL, you need to know where the connection is being connected. For example, D0 is connected to this and this pins. Okay, for D1 it is connected to these lines. Okay, D2 is connected to this line, and D3 is connected to the first and second line. So you need to know what is the connections which is being connected to each output, so that you will be able to program the AND array correctly. Alright. So next is GAL. Okay. So generic array logic has the same basic structure as PAL. So programmable AND gates, all connections are fixed. But being EEPROM-based, it can be erased and reprogrammed. So GAL improves upon PAL in 3 aspects. For the first aspect is it can be erased. So the second aspect is it can be programmed while installed in circuit. And the third improvement is it has programmable output stage or macro cell that has feedback to enable product term to be expanded and complementary output. Okay, so actually GAL is the improvement of PAL, okay, because we can erase that and we can program while installed in circuit, and it has programmable output stage. Okay, so basically the GAL has the same structure as PAL, but the advantage of GAL is inside this what we call explanation. All right, so I think that's all for this chapter. Okay, so I hope that you will be able to know what is actually PLA, PAL, GL, and also RAM and ROM. All right, so that's all for today's. Thank you.